Hi, I am Sushma, working as Assistant Professor in the Department of ECE in Institute of Aeronautical Engineering College. In this session, we are going to discuss about the filtering the long duration sequences. We have two types of methods in this: overlap add method, overlap save method. So, in this session, we are going to discuss about the overlap save method. Filtering long duration sequences. In a real-time signal processing scenario, an input signal is constantly fed into the DSP to be processed, and the associate output is made ready without much delay. So, if we had a long input signal but continuous in time indefinitely, we don't want to wait until the entire input signal has terminated before filtering it. So, we would like to filter the blocks of input as they come in. So, here we know already LTI system, we are taking any system or LTI system. So, for that input is X of n, or the impulse response of system is H of n. Then the output response will be the X of n convolution with the H of n. So, if X of n, whatever the input is there, if it is a long duration input, if we want to convolute with the short duration of H of n, then it will be time delay process. So for that we are going for the two processes, overlap add method and overlap save method, to filtering the long duration sequences. So here, suppose the input sequence X of n of long duration is to be processed with the system having finite duration impulse H of n. By convolving the two sequences, we will get the Y of n. So it will take the much delay. So to avoid that one, and to store the linear convolution of long duration input sequence convolution with the H of n, it will be difficult. So we have to make the X of n, whatever the input, long duration input, we have to segment that input into the blocks, and we have to convolute it with the impulse response of the system with H of n, and at the end we have to add these individual output responses of the segmented blocks we have to add. So for that we have two methods, overlap save method and overlap add method. So since linear filtering performed via DFT involves operation on a fixed size data block, so the input sequence is divided into different fixed size data blocks before processing. So whatever the X of n input, long duration input we have, so this is X of n. So the long duration input, we have to segment these input blocks, and we have to get X1 of n and X2 of n like that. And each segmented block will be convoluted with the response of the system, impulse response of the system. We will get the individual output responses. At the end, we have to coordinate these outputs. So for that we have two procedures. So the successive blocks are both then processed one at a time, and the results are combined to produce the net result. So the as a convolution is performed by dividing the long input sequence into fixed size input blocks, that are X1 of X of n will be divided into different fixed size sections, that is X1 of n, X2 of n. Like that, it will be segmented into blocks. Then that's why it is called as a section convolutions. This filtering the long duration sequences is also called as the section the convolution. A long input sequence is segmented to fixed size blocks prior to FIR filtering process. This is the procedure for the filtering the long duration sequences. So there are two methods for segmenting a long input signal into shorter blocks. The processing them quickly, we will use the FFT process here. Okay. So here we have two methods for filtering the long duration sequences. So that is nothing but we have the input for the system. We are getting the continuous input signal X of n, otherwise a long duration input X of n. It should convolute with the system impulse response, which has the short duration H of n. So for that, we have to segment the inputs into the blocks, and we have to convolute each segment block with the impulse response of the system. and we will get the particular outputs y1 of n, y2 of n, like that. We have to concatenate the outputs at the end. Okay, so for that we have different procedure: overlap save method and overlap add method. Today we are going to discuss about the overlap save method. So first we will discuss the steps of overlap save method, and we will do one problem in the overlap save method. So in step 1, so here determine the, it has a system, LTI system satisfy the additivity property. That's why we at the end the output responses y1 of n and y2 of n, those will be concatenated. So it has a long duration sequence x of n and impulse response h of n. Output we have to get y of n. So first we should know how to segment the long input sequence x of n, and how to convolute those blocks with the h of n, and at the output we will get the different y1 of n, y2 of n, each individual output responses of particular blocks, and how to concatenate these output blocks. Okay, in step 1, what we have to do? So here determine the length m, which is the length of the impulse response. So here we are taking the impulse response h of n for the system. So we have to find out the number of samples in that is called m, capital M. From that, if we know m, we can write m minus 1 value. Okay, in step 2, given input sequence x of n, size of DFT is n. So here let us assume n may be n is equal 5, you can assume 6, we can assume 4, we can assume. So here we can assume n value. N is nothing but we are segmenting the each block. X of n is a long duration input. After segmenting, we are getting different blocks, x1 of n, x2 of n, x3 of n, like that. So each block length should be capital N. So this we should assume that value. It may be n is equal 5 or 6 or 4, we can assume here. So here I am assuming n is equal 5. That is nothing but the segmented blocks should contain 5 samples in that, 5 input data. So here we know the linear convolution, the length of the sequence is L plus M minus 1. So here we are assuming n value. We know n value and we know the M minus 1 value. From that we should find out the L value. Okay. So here L is nothing but we have the input x of n. So we have to write these L values. Divide into L samples. Input should be divided into L samples. Each x of n is input should be marked as L samples. So next in step 4, pad L minus 1 zeros to h of n. So here we have in h of n we have m bits. So we have to pad L minus 1 0. So total length of this one is, already here we have L. We are adding L minus 1. So L plus M minus 1. We are making the length is equal to L plus M minus 1 inputs in the h of n. So for that we should add L minus 1 zeros to your h of n. Already we are finding L in the step 3. So we have to add L minus 1 zeros to h of n. So here this is the procedure to segment the blocks using overlap save method. So here we have input x of n. So input is divided into L bits. First of all we have to divide into L bits. So here input is divided into L bits. How to get the first x1 of n means, the first x1 of n, the first we have to add m minus 1 zeros to n minus 1 zeros, and next bits are followed by the L bits from x of n. This is x of n. So m minus 1 zeros is followed by L bits of x of n. So the total length of x of n is n is equal L plus m minus 1. Here we are assuming in the step 2, we are assuming n value n is equal 5, suppose. So I should get the 5 samples in x of n. So for that we have to add m minus 1 zeros. M is the length of the impulse response h of n. So we have to add m minus 1 zeros in the first bits of the x of n is followed by the L minus L bits from the x of n. So whatever the L bits are there, those will be coming to the x of n here. So to get the x2 of n segmented blocks, so the samples, so here the last m minus bits, last m minus 1 bits of x1 of n will be coming to the first bits of m minus 1 bits of x2 of n. So here, suppose here I have n 1 comma 0. These 1 comma 0 bits will come here. So the last m minus 1 bits will come to the x2 of n. And next m minus 1 data of the previous segmented block and is followed by the next new L bits of x of n. Next new L bits of x of n. So first L bits will go to the x1 of n and next L bits will come to the x2 of n. So to get the x3 of n, what we have to do? Here the first bits will be the m minus 1 bits of the previous segmented block. So here m minus 1 bits of x1 of n, x2 of n and is followed by the next L bits of x1 of n. Next L bits of x of n. Okay. So x4 of n. So x4 of n is m minus 1 bits of x3 of n. Last m minus 1 bits of x3 of n is followed by the next L bits of last L bits of x of n. So this is the procedure to segment the blocks by using overlap save method. Here what we are doing in the x1 of n, first m minus 1 zeros we are adding is followed by the L bits of x of n. So the total each x1 of n length should be n. N we are assuming in the step 2. So that number of bits should be contained each block. So here the total number of bits is n. N is equal to L plus m minus 1. Already we have L minus 1. We are adding m minus 1 zeros for x1 of n and L bits we are taking from the x of n. First L bits of x of n. And x2 of n, here the first m minus 1 bits will be the last m minus 1 data of previous segmented block, that is x1 of n, and is followed by the L bits of next new L bits of x of n. So these next L bits will come to here. And for x3 of n, you will get the first m minus 1 data will be the last m minus 1 bits of x2 of n and is followed by the next L bits of x of n. Like that we have to segment each block with the number of samples capital N. So each segmented blocks should contain number of samples are capital N. So we are here in step 6. What we are doing here, we segmented the input x of n long duration sequence into x1 of n, x2 of n and x3 of n like that. So but the system has impulse response. The system has impulse response h of n, which is a short duration sequence. So we can convolute each segmented block with the h of n. Each segmented block with the h of n. So we will get the y1 of n, y2 of n, y3 of n. Like that we will get the individual output responses of the particular blocks. Here we are performing circular convolution. We have to perform the circular convolution for the each segmented block with the impulse response h of n. So after getting the y1 of n, y2 of n, y3 of n, how to concatenate the output, final output means we have to take the total, this is y1 of n and this is y2 of n, y3 of n, suppose y4 of n. Okay, so the first m minus 1 bits will be discarded for the each block of individual output responses. So the first m minus bits of the y1 of n will be removed and m minus 1 bits of the y2 of n, m minus 1 bits of the y3 of n, m minus 1 bits of the y4 of n bits will be removed and the remaining bits will be coming to output. So the remaining total output will be the remaining bits will be directly concatenated to the output. So y1 of n, y2 of n, the remaining bits will be coming to the output. So this is the procedure to find out the final output response in the overlap save method. So here we are taking the input x of n, we are adding the m minus 1 zeros for the first segmented block and next bits will be followed by the L bits of the input and next m minus 1, last m minus 1 bits of the x1 of n will be coming to the first m minus 1 data bits for the x2 of n and the next bits will be next L data from the x of n. So like that we have to segment each block and we have to convolute with the each block will be convoluted with the impulse response h of n and we will get the response total y1 of n and y2 of n and y3 of n. After getting the individual output responses of the segmented blocks, we have to discard the first m minus 1 bits. M is the length of the h of n. So we have to discard the m minus 1 bits from the y1 of n, first m minus 1 bits from the y2 of n and next first m minus 1 bits from the y3 and the remaining bits will come to the output. So here if overlap save method using FFT. So here we are doing in the previous method we are doing circular convolution, but if the input is a long duration input, if it convoluted with the impulse response of the system h of n, so here it will take the time delay process. So here for that we would like to filter the blocks of input filter these blocks quickly. So which means the use of the fast Fourier transform. So in fast Fourier transform, what is fast Fourier transform? It will convert the time domain signal into frequency domain signal. So what is convolution? The relation between the frequency domain and time domain? The multiplication of the frequency domain signals individually is equal to the convolution of the time domain signal. So here we are using this FFT fast Fourier transform algorithm to increase the speed of the convolution process. So for that what we have to do, same procedure for the up to step 5, that is nothing but we have to up to segmentation process x1 of n, x2 of n, x3 of n. The procedure will be the same. We have to segment the for x1 of n, we will get the m minus 1 bits zeros and next L bits from the x of n. For x2 of n, the last m minus 1 bits will come to the first bits of the x2 of n and it will be followed by the L bits. Like that we have to segment the input. So same procedure we discussed in the previous slides. So after that, after segmentation, we have to use the fast Fourier transform algorithm. Why we are using? Here the multiplication of the frequency domain signal is equal to the convolution of the time domain signal. So here we are getting the individual segment blocks here. So we have to by using the FFT algorithm, we have to convert them into frequency domain, frequency samples. So, okay, x1 of k, x2 of k, x3 of k, and h of n, by using the FFT algorithm, we have to convert that into frequency domain signal h of k. So here in the step 2 up to step 5 is the same procedure as above, a segmentation process to get the x1 of n, x2 of n. And in next what we have to do, take endpoint FFT of h of n and save for repeated access in the future. That is nothing but we have to apply FFT algorithm and we have to get the h of k, frequency domain signal here. Okay, and take the n FFT of each n length input blocks xk of n and save. So that is nothing but we have to apply FFT algorithm for x1 of n. We will get the frequency domain signals x1 of k and x2 of k, x3 of k. Okay, so multiply sample by sample the FFT of xk of n with the h of k. Okay, so here hk of k is multiplied with the, so here multiply the sample by sample the FFT of xk of n is xk of k, frequency domain signal, and FFT of h of n is frequency domain signal of h of k. So each block will be multiplied with the frequency domain sample of impulse response, and we will get the y1 of k, y2 of k, y3 of k, and the further to get the time domain signal y1 of n, y2 of n, y3 of n, we have to apply the inverse Fourier transform. We have to apply the IFFT to get the y1 of n, y2 of n, y3 of n. So here after getting, so here that is step 5. So we have to apply inverse endpoint FFT of the result from the above step and discard the m-1 samples. So here we are getting y1 of n, y2 of n, and y3 of n like that. First, from that we have to discard first m-1 samples and we have to concatenate the L samples of each block to produce the overall output. This is another procedure to find out the overlap save method using FFT to increase the speed. So we will see one problem here. So given x of n is equal, here the length x of n sequence is 3, -1, 0, 1, 3, 2, 0, 1, 2, 1, and h of n is equal 1, 1, 1. Perform linear convolution using overlap save method. So here we have to perform overlap save method to filter the long duration sequence x of n. So here first I am assuming the n value. I am assuming it is 5. We can assume it is 6 or 4 also. Here I am assuming n is equal 5. So what is n here? N is nothing but after segmentation we are going to get x1 of n, x2 of n, x3 of n like that. So each block should contain n samples. Each segmented block should contain n samples. That is nothing but 5 samples. Each segmented block should contain 5 samples here. Okay. So in step 1, here first step 1, what is step 1 here? First find out the length of impulse response. So impulse response is here 1, 1, 1. So here we have 3 samples. So capital M is 3 samples. From that m-1 will be 2. Okay. And we are assuming n value. We know n is equal L plus m-1. We are assuming n value and we know m-1. So from that L is equal 3 we should get. So we have to find out the L value. L is nothing but it will, the long duration sequence x of n will be divided into L bits first. Okay, not segmented value. X of n will be divided into L bits. So here this is my x of n given in the problem 3, -1, 0, 1, 3, 2, 0, 1, 2, 1. Okay, so L we have 3. L is equal 3. We in the previous step we got L is equal 3. So each x of n has the, we have to divide into 3 bits. Okay, and how to write x1 of n value? First segmented block x1 of n. Here it will get the first bits will be m minus 1 zeros. First bits will be m minus 1 zeros is followed by the L bits from the x of n. So here L bits are 3 minus 1. First L bits are 3 minus 1 0. So these bits will come here. 3 will come here, minus 1 and 0. The first L bits will come to x1 of n here. So the first bits are m minus 1 zeros and is followed by the L bits from the x of n. First L bits from the x of n. So total how many bits we have? 1, 2, 3, 4, 5. So here n is equal 5. So each segmented, we are assuming 5. So each segmented block should contain 5 samples here. In x2 of n, x2 of n also has should contain 5 samples, segmented block n value. So here the first m minus 1 bits will be the last bits m minus 1. M minus 1 is equal 2. So last 2 bits of x1 of n will be the first 2 bits of x2 of n. So here last 2 bits are minus 1 0. These 2 will be the first bits of m minus 1 bits of x1 of n. Last m minus 1 bits of x1 of n. So the last m minus 1 bits are minus 1 0 will come here, and next segmented value, next L values are 1 3 2. So already 3 minus 1 0 we added in the x1 of n. Here 1 3 2. So 1 will come here, 3 will come here and 2 will come here. So 1 3 2. So here x2 of n is equal, the first bits are the last m minus 1 bits. That is nothing but m minus 1 is 2. So the last two bits of x1 of n is followed by the L bits, next L bits of x of n. And x3 of n is the last m minus 1 bits of x2 of n. M minus 1 is 2. So the last 2 bits of x2 of n and is followed by the next L bits. So 0, 1, 2. The remaining we have only 1 here. So here for that x4 of n is last m minus 1 bits of x3 of n, and with this only 1 will come. Remaining bits we have to add 0, 0 because each segmented block should contain length n. Each segmented block should contain length n. We are assuming n is equal to 5 here. Each segmented block should contain 5. See here last bit we have only 1. So remaining bits we have to add the zeros for x4 of n. So here in overlap save method we have to segment the x of n with x of n with the x1 of n, x2 of n, x3 of n, x4 of n. How we are dividing? For x of n, the first bits are the m minus 1 zeros. M minus 1 is 2. So 2 zeros we are adding, first 2 bits. And is followed by the next L bits from the x of n. First L bits from the x of n. x2 of n is the first bits are m minus 1 bits of the previous segmented section. So here x1 of n is has last bits are 2 bits are minus 1 0. These will be the come to the first bits of the x2 of n is followed by the next L bits from the x of n. So 1 3 2. For x3 of n, this is m minus 1, last m minus 1, 2 bits are 3 2 is followed by L bits of x of n. Next L bits are 0 1 2. And x4 of n, here last bit we have 1. So for x4 of n, these 1 to last m minus 1 bits of x3 of n is followed by the last bit from the x of n, and the length should contain 5. N is equal, we are assuming 5. So each segmented block should contain 5 samples. So the last 2 bits we are adding zeros. So from this, in this step we are segmenting the x of n into x1 of n, x3 of n and x4 of n. If we use the FFT, what we have to do? We have to find out the frequency domain signals, frequency domain signal by applying the FFT algorithm, and we have to multiply with the h of n. If we apply FFT algorithm, the time domain signal is converted to frequency domain signal. So each individual output block will be multiplied by the frequency domain of impulse response. Here we will get the y1 of k, y2 of k, y3 of k, and y4 of k frequency domain signal. But we to convert the into time domain signal, y1 of n, y2 of n, y3 of n, we have to apply the inverse fast Fourier transform. So if we apply the y1 of k, if we apply the inverse fast Fourier transform, we will get the y1 of n, y2 of k. If we apply the inverse fast Fourier transform, that will convert the frequency domain signal into time domain signal, y2 of n, and for y3 of k, we will get the y3 of n, and y4 of k, we will get the y4 of n. And we have to concatenate these y1 of n, y2 of n, y3 of n, and y4 of n by discarding the first m minus 1 bits. This is procedure using FFT. Otherwise, we can do here by yk of n is equal to xk of n circular convolution with the HA. We have to perform each individual block with the convolute with the impulse response of that system h of n. So here, if we substitute case call 1, first segmented block x1 of n is circular convolute with the h of n. So the x1 of n samples are, here we are getting in the first block what we get the 0, 0, 3, minus 1, 0. So that is we are at 0, 0, 3, minus 1, 0. H of n is 1, 1, 1, and we have to add the L minus 1 zeros. Add the L minus 1 0. So that is 0, 0 we are. So we have to perform the circular convolution for that one. So how to perform circular convolution? 0, 0, 3, minus 1, 0. Okay. And this 0 will come first and these bits will come down. 0, 0, 3, minus 1 and minus 1, 1 come here. 0, 0, 3 and 3, minus 1, 0, 0, 0. Okay. And 0, 3, minus 1, 0, 0. If again we rotate this sequence, we will get the first sequence. So we have to stop here and 1, 1, 1, 0, 0. This is x1 of n. We are circular convoluting with h of n. So just we have to perform matrix multiplication. We will get here 1, 0, minus 1, 0, 3, 2, 2. This is y1 of n. Okay. So here we if we use fast Fourier transform, we have to convert the time domain signals into frequency domain signals, and we have to multiply that individual frequency domain samples of the segmented blocks with the frequency domain sample of the impulse response, and again we have to apply the inverse fast Fourier transform for the output responses, and we have to discard m-1 bits. Otherwise, we can perform circular convolution with the impulse response and each individual block. So here we got the y1 of n. To get the y2 of n, it is x2 of n circular convolute with the h of n. That is nothing but, so here x2 of n is minus 1, 0, 1, 3, 2, 2, minus 1, 0, 1, 3, 3, 2, minus 1, 0, 1, 1, 3, 2, minus 1, 0. We have to take the first bit to the last bit to the first, and we have to make the next bits down. So stop it here, and this is x2 of n, and h of n is 1, 0, 0. And we have to perform matrix multiplication. We will get 4, 1, 0, 4, 6. This is y2 of n. Okay. And to get the y3 of n, we have to perform the x3 of n segmented block with the circular convolution with the impulse response h of n. Each segmented block x1 of n, x2 of n, x3 of n, x4 of n will be convoluted, circular convoluted with the impulse response h of n. Okay. So here x3 of n is 3, 2, 0, 1, 2 and impulse response is 1, 1, 1, 0, 0. So here x3 of n is 3, 2, 0, 1, 2, 2, 3, 2, 0, 1, 1, 2, 3, 2, 0, 0, 1, 2, 3, 2, 2, 0, 1, 2, 3. If we again rotate the last bit to the first and if we make the next bit down, we will get the first row. Okay. Stop here. 1, 1, 1, 0, 0. This is x3 of n and this is h of n. We are performing circular convolution. Here just we have to do matrix multiplication. Then we will get the sample 6, 7, 5, 3, 3. This is y3 of n. Okay. We have x4 of n also. So we will get the y4 of n. So y4 of n is x4 of n circular convoluted with h of n. Samples of x4 of n is 1, 2, 1. Last bit we have to pad zeros because we have only last bit remaining of x of n is 1. So we are adding 0, 0 to make the length n. And h of n is 1, 1, 1, 0, 0. So here same procedure. We have to perform matrix multiplication, matrix method for circular convolution. This is x4 of n and 1, 1, 1, 0, 0. H of n, it will be perform matrix multiplication. We will get 1, 3, 4, 3, 1. So this is y4 of n. So here by performing circular convolution of individual segmented blocks with the impulse response, we are getting output responses of individual blocks as y1 of n, y2 of n, y3 of n and y4 of n. So how to concatenate these segmented output responses means, so here we are getting y1 of n, y2 of n, y3 of n values. So here the first y1 of n we have to write y2 of n, y3 of n, y4 of n. The first m-1 bits will be discarded. Each output responses of the individual blocks will be from the first m-1. M-1 is m is 3. Impulse response h of n has 3 bits. So m-1 is 3. So here m-1 is 2. M is equal 3. So m-1 is 2. So here we have to discard first m-1 bits of the y1 of n, y2 of n and y3 of n and y4 of n. So we have to discard these first m-1 bits from the y1 of n, y2 of n, y3 of n, y4 of n. The remaining L bits 3, 2, 2. So these 3, 2, 2 will come here. The remaining bits 0, 4, 6. So 0, 4, 6 will come here. 5, 3, 3, 5, 3, 3 and 4, 3, 1. 4, 3, 1. So we have to discard first m-1 bits of the each individual output responses of the segmented blocks. So y1 of n, y2 of n, y3 of n, y4 of n and remaining L bits will come to the y of n. So 3, 2, 2. The remaining bits from y2 of n is 0, 4, 6 and remaining bits 5, 3, 3 and remaining bits of y4 are 4, 3, 1. So this is the final output response is y of n is 3, 2, 2, 0, 4, 6, 5, 3, 3, 4, 3, 1. This is by using the overlap save method. So here, what is the procedure first of all? First in step 1, in overlap save method, first we have to take m. M is the length of the impulse response. From that find out the m-1 and in step 2, assume n value. N may be 5, 6, 4, okay. We have to assume n value. N we know L plus m-1. So from m-1 we got from the impulse response length and n we are assuming. From that we have to find out the L value. L is nothing but whatever the long duration sequence, we have to point the LL bits. Mark L bits. Okay. And in step 3, we have to pad, it has the M bits, we have to pad L-1 zeros to the impulse response H of L. So here you will get the h of n. This is L minus 1. Total length we should make L plus n minus 1. In step 4, we have to segment x1 of n. x1 of n is first bits are m minus 1 zeros and last bits are L bits of x of n. The first L bits of x of n. For x2 of n, the first bits are m minus 1 bits of previous segmented, last m minus 1 bits of previous segmented block. We will get the first bits of x2 of n is followed by the next L bits of x of n. And like that, x3 of n is the last m minus 1 bits of previous segmented block and next L bits will come here. Like that, we have to segment by using overlap save method, and we have to perform circular convolution x1 of n, circular convolution with h of n, and x2 of n, circular convolution with h of n, x3, that is we will get the y2 of n, y3 of n is x3 of n, circular convolution with h of n. Okay, like that we have to find out the individual output responses of the individual segmented blocks, and we have to concat output out by discarding m minus 1, first m minus 1 bits of y1 of n, y2 of n, like that, and the remaining L bits will come to the y of n. This is the procedure for overlap save method. If we want to increase the speed of this linear convolution while doing filtering, because we are getting the long duration sequence, it is a time delay process. So to increase the speed of that convolution process, we have to repeat this step by using FFT. So FFT is a fast Fourier transform. We will convert the time domain signal into frequency domain signal. Here we have to perform FFT, fast Fourier transform. We will get the frequency domain signal. For HFN also we have to apply FFT, fast Fourier transform. We will get the frequency domain impulse response. x2 of n, apply FFT, fast Fourier transform. We will get the x2 of k. Like that, we have to apply the each individual segment blocks. We have to apply the fast Fourier transform algorithm to get the frequency domain signals. And in convolution, the multiplication of the two signal is equal to the convolution in the time domain signal. So that's why we have to multiply the x1 of k with the h of k. We will get the x1 of n convolution of h of n. Okay, so here we will get the y1 of k. So like that, we have to multiply the each individual frequency domain segmented blocks with the frequency domain signal of impulse response. We will get the y1 of k, y2 of k, y3 of k, like that, and apply inverse fast Fourier transform, which will convert the frequency domain signal into time domain signal. So we will get the inverse fast Fourier transform. We will get the y1 of n, y2 of n, y3 of n, like that, and discard the first m minus 1 bits of these output responses of the individual segmented blocks, and next remaining L bits will come to the output. This is the procedure for the overlap save method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.